So,
yes.
so one of the questions that everybody asks, whenever they see a balancing robot, is how does it balance? So, I just wanted to try and give a quick explanation. It's balancing robots are kind of, first of all, they're not statically stable. So if you shut off the power, it's going to fall over. The only way that it knows how to balance is actively. So it's kind of like balancing a broomstick on your hand, or balancing anything. If you balance an object like this, if the object tilts this way, you've got to move your hand underneath it. And so with the robot, it's the exact same thing. If it tilts forward, it knows to move the wheels forward. So if it tilts forward, the wheels move forward to get underneath the robot and bring it up to balancing again. And so the way that it knows that it's tilting is that it has what's called an IMU, Inertial Measuring Unit. And there's two parts to that. There's an accelerometer, which determines where the direction of gravity is, and then there's a gyroscope, which determines how quickly it's rotating. And so if you take both of those measurements together, you can figure out what is the angle of the robot relative to the ground, and then based on that, you know whether to move the wheels forward or backwards. So it's not perfectly stable, as you can see. He's got kind of a slight oscillation to him, and that's something that is kind of like a more advanced part of robot control, which is what's called PID control, where you use algorithms to cancel out either differences in speed. That's where, Jim, what you're going to have to get into is PID control, so you can make both wheels go perfectly straight. Or in this case, it's used to help it balance. So the only reason why I'm keeping it will balance by itself without any help, but it's just kind of a small space, and I don't want it to fall off the table. So anyway, that's balancing robots. It's another class of robots. It's the one that I'm most interested in. I'm very interested in humanoid type robots, and robots that people can relate to, things with faces, because even though the face isn't active, you instantly gravitate to the face and you attribute the robot characteristics which it doesn't have. So anyway,
where are your sensors?
So all the electronics are in here.
The ham and the sandwich.
It's actually just, pardon?
The ham and the sandwich.
Yes, yes. So it's an Arduino. So you don't need complicated electronics to build a robot that does complicated things.
What do you use for motor controller?
So for a motor controller, it's an off-the-shelf Pololu motor controller, and I use the Pololu motors. These are the 37D motors. Wonderful motors. They have very good encoders built into them, which is another thing you need, Jim. But these motors are, like $40–50 each, as opposed to some of the more cheaper motors that you'll see on the tabletops robots, which are probably $3 to $4 each. How much were the ones that you used on your robot, Jim?
I think they were like $2.99 on eBay, and it took 4 weeks from China.
Yeah.
Yeah.
So, yeah, the more expensive motors you get, the better control you have. But as somebody mentioned it, I think it was it Michael, so somebody over here, even if you have $500 motors, you still need that feedback in order to make sure that they both behave the same. Yeah, Rohan.
So you said you're using those Pololu 37D motors.
Yeah.
Have you had problems with backlash on those when you're trying to do balancing?
Yeah, so there's a lot of things, in order to refine motor control, backlash. What backlash means is that when you reverse direction, it doesn't instantly go back in the other direction. There's a slight dead zone that you have to pass through before it actually starts moving backwards. So there are things, yes, there is some backlash in these, but I try and get around it with fancy programming. For example, I know what the backlash is approximately. So when I reverse direction, I know that I need to initially give it a little bit of direction before the main control loop starts. So there's things like that. So anyway,
your accelerometers and gyroscopes are in the cell phone, or?
So actually, the cell phone is just for decoration, really. There's nothing going on.
Those aren't real eyes.
Yeah. Believe it or not, it really does not see. So all the control and electronics is with the Arduino and the discrete electronics down here. Yeah.
So, with robots like these, are they better if they're a little taller? Does that give you a better ability to swing underneath, or does that matter so much?
There is a lot of discussion about where you put the center of gravity in a balancing robot. My experience is that it doesn't really matter. You know, I think it's fine if it's pretty much evenly distributed. So somewhere in the center. You don't want it down too low because then it's not really a balancing robot anymore. It certainly has to be above the axis of the wheels so that it's statically unstable. But yeah, I found it doesn't really matter too much. So anyway,
My announcement is I'm doing a robotics class this weekend. Come see me if you don't know what a BLDC is and you want to find out. We provide a bunch of tools in toolkits.
Excuse me, you said BLDC?
Yeah, if you don't know what that is, if you don't know what a BLDC is.
Oh, yeah.
So we provide you with tools, and you can use them during the class. And the robot, here's one of them. There's a couple different behaviors it will do. We provide you with all the parts for the robot also, as well as a list of where we get them from, so you can go and get the stuff for yourself. Let's see. Ta-da!
All right. Yay.
It's staying still. It's actually keeping fixed distance to the thing in front of it. And if I move this right, it's kind of a lie. It kind of looks like it's following whatever's in front of it, but it's actually running a really simple program. It's just keeping this distance, that fixed at that length, and then this distance fixed at that length by either rolling this wheel forward or backwards or this wheel forward or backwards. So if you don't know how to do robots at all and you want to, this would be the class for you. This is one thing that it can do. This is based off of Wayne's work from years ago. I took that class and learned how to make a robot because I had been into software and I really wanted to learn how to do hardware stuff. And then this robot should do the tabletop challenge.
Woo!
It's going to do a very short
small
version
table.
of the tabletop challenge.
Awesome.
I'll let it do the longer version on the table. Oh, not that long though. This way. So what it's doing is, it's all the same hardware, but the software is slightly different. So what it's doing is detecting either a short distance or a long distance when it gets over the edge of the table, and then it knows to stop. And there, it just did the tabletop challenge technically.
Yay!
Yay! So
Start.
if you're interested in doing that, oh yeah, can I show them that thing? All right. So yeah, if you're interested in that, come see me or email reserve@challengebot.com. Yes?
So what level of programming is required for this, or are you starting from scratch on both hardware and software?
Oh, you would be starting from scratch on both hardware and software, and you start off with a box of parts like this, and then you go home with the box of with a robot in a box. And you can color the box however you want. You can see this one's been colored, and you can put your name on it. The class is $195, and that is it's 4 hours on Saturday and then 4 more hours on Sunday. It's going to be at the Hacker Dojo, and yeah, go to challengebot.com and you can see all the info about how to reserve a spot.
You're posting on the mailing list too, aren't you?
Yeah, it should already have been
Everybody's
posted.
on the mailing list?
Yeah, so if you're interested, get on the mailing list. I believe it was already posted there. I guess I could post it again. Yeah.
Is there an Arduino in there, or is it just
It's an Arduino. So we provide you with tools during the class, and we also have spare parts, because a really common problem is people lose the tiny little parts like the screws and nuts and stuff. Yeah, and that's it.
Do you need a laptop?
Yes, you should bring a laptop. You should bring your own laptop. And we'll help you install. It's all open source. It's all Libre. You're allowed to do whatever you want with it. And you can compile it on your own hardware if you want to. Any other questions? Cool. Come see me or email reserve@challengebot.com. Thanks.